Next thing we're going to learn is how to use a graph to find the graph of an inverse function. What we have here in red is the graph of the function x plus 1 raised to the third power. And what we want to be able to do is graph the inverse of the function. So the first thing we want to be able to do, if we look over here on the left side where the graph is identify a couple of points on this graph. So if I look where it hits the grid, this first point here looks like it hits the grid at -2, -1. I'm going to put that down so I know that this is one of the points on my original graph, -2, -1. I'm going to plot that to make sure that I know where that point is. So that point's going to be point A. Another point that I can locate right here is the point -1, 0. So I'm going to put that -1, 0 because it's left one and not up and down any. So -1, 0, put that on the graph. I can see that point is point B. The third point I see is the point 0, 1, where it crosses the y-axis. If I plot that, we can see where that's at for sure, is at point C. Now the nice thing about finding inverses graphically is I can take these ordered pairs of x's and y and just change the position of them for the inverse. So I'm going to switch colors here to green, and I'm going to use this to help me find the inverse function, and this is how I notate it as an inverse of x. So if I create a table for x and y of the inverse, what I should see is -1, -2, 0, -1, and 1, 0. All I did was take the x's and y's from f of x and switch their positions. So I'm going to go ahead and plot those 3 points. So -1, -2 should be left 1, down 2, and we see that's where it is. If I plot the point 0, -1, that's going to just be down 1. And then if I plot the point 1 and 0, that's going to put me right there. Now, they kind of look like they're in a straight line, but I don't want them to be in a straight line. What I actually want to happen is for this to reflect over the line, y is equal to x. So I should have the same type of curves around this line on one side as I do on the other. So I'm going to go ahead and graph it in green so we can see what it should look like. Notice if we look at our graph that it is a direct reflection across that graph. Every curve on the upper side in red is reflected in the curve on the lower side in green. So that's the nice thing about these graphs and their inverse functions, is I can take an initial set of points, exchange the order of them, and then graph a reflection based on where those points are without too much trouble.